Okay, you may recall from an older video I had built something similar to this. This is the same basic concept. It's got a pedostatic sensor on it, an altimeter, a magnetometer, a power supply for the microcontroller, and a battery. This is a little bit different. This uses a fair bit less power, and as it turns out, it's actually easier to code for the microcontroller because most of these are written for designed for microcontrollers, and all the libraries that are available for all these sensors are for Arduino and stuff like that. And getting the libraries and stuff to work with the Raspberry Pi was a little bit of a chore, and this uses less power, so it's kind of a win-win. The Raspberry Pi was kind of overkill for that project. A real quick note before I get on to the first part of this video, which is just kind of explaining all the new stuff that's in Stratofier. I'll just quickly explain what this is. This is the exact same concept as that other project with the Raspberry Pi Zero W, except it's got a Heltec microcontroller with a tiny little display on it. It does have Wi-Fi, and Bluetooth and stuff, but I'm not using that. It has the exact same pedostatic sensor. It has the same 9 DOF sensor with the magnetometer. The same altimeter. What's different with this one is this is using it's actually one that I already had. It's a little power converter for the battery voltage to the 5-volt USB to give you a constant supply regardless where the battery is at. The reason there's this one and this one, which is a charging circuit, is this pulls just over an amp in total, and this is rated at 1 amp, and it just can't supply enough current, so it keeps cutting out. It works fine as a battery charger, but so I just hooked it in parallel for now. The final version will just have one of these, and it probably I'm going to see if I can find, if such a creature exists, one of these without a display, because the display isn't necessary for the final version. It's just handy for development. If I can keep this in the center of the camera. I'm going to see if I can find one of these that has a charging circuit built in. I don't know if that creature actually exists or not, but if it does, I can make it even smaller. If not, I'll probably ditch this and just use that, because it'll be able to handle the current. So that's kind of an overview of that. So this is going to be kind of a 2-in-1 video showing kind of what Stratux is and the different changes that have been made to it. So I guess I'll just go over the features real quick, because I really want to talk more about this than Stratofier, because there's not a whole lot to Stratofier. It's mainly a dumb display for the Stratux. So I'll just dig right in. The main thing here is the menu. It's a little different than before. It's got the buttons are colored differently, just so it's a little easier to see, and they're a little bit bigger. I put them in 2 rows instead of 1 because there was enough buttons that it was getting really small, especially in landscape mode. With that many buttons in 1 row, they were getting so small that it was difficult to operate. So that's the new menu. A lot of this stuff is the same. Probably some of the stuff that I haven't gone over is the data stuff. So I'll go into settings, and this is where you configure whether you've got switchable tanks like wing tanks, or if they just all feed into one and you've just got one either virtual tank or actual tank. Like a Cessna doesn't have or a Cessna 172 doesn't have a tank switch, whereas a Cherokee does. So that's what that's for the fuel estimator. The magnetic deviation, before there was kind of 2 arrows here, and I thought, well, you're not going to be messing with that all the time. Why not put it in the settings so it's not cluttering up the display? So I moved it into the settings. So that's how you change your magnetic deviation. So if you're doing a long cross country where the magnetic deviation actually does change, you can just quickly go into the settings and change it. But if you have one of these, you don't need to, and I'll get to that. So to select which country data you want, and the reason this list is what it is because these are the major countries that have open AIP airspace and airport data. Not every country has enough data to bother with, which is why this short list isn't 50 countries long. It's only the larger countries that also have the airspace data for them in the AIP data, because it's open source, and if nobody's put it in there, then it just doesn't exist. This isn't accessing the FAA data because it's expensive, and this is free, so that's why. So this first tab is the airspace, and you can see I've already got United States and Canada selected, and you can go in here and select whatever you want, but I don't want, so I'll leave them unselected. And the other tab is airports, and there's more airport data than there is airspace data. If you live in one of these other countries, at least you'll have airport data. United States and Canada coverage is extremely good. I haven't really looked at these other countries, how good the data is, how complete the data is. The United States is probably the most complete. So you select the countries that you want in there and hit OK. And you need an internet connection to retrieve the data on here. So if I go into here and change this to my home Wi-Fi, and then go back in and select Get, you can see it's downloading the data. From what it'll do is it'll show you it's downloading the U.S. Airports, and then the U.S. airspace, and then the Canadian airports and the Canadian airspace. So I'll let this continue, and I'll cut out all the boring download time and come back. Okay, we're back. And I'm going to go back to the Stratux, because we are pretending we are in the plane. And you'll notice those indicators immediately come back because we're getting status back from the Stratux. Yes, I know. Okay, here's where you'll enter the IP of your Stratux. Normally, you don't have to set that because it's always 192.168.10.1. I've got a little pigtail on here that I use for testing on my network, so I plug this into the network, and that has a different IP, so that's kind of mainly for my usage. But if you've built some custom setup and you've got a different IP, then you can put it in there and it'll still work. That's where you'll enter your tail numbers, so it knows to ignore your own ADS-B receiver. Otherwise, you'll have a red indicator saying somebody's right on top of you because it's you. Okay, when you're done with the settings, done. And that's pretty much it for the settings. So I'll move on to when you click on help, it just brings up Chrome and it brings up the user manual. And depending on when you see this, you may be looking at the older user manual. So just give me time. I'll get it updated with all the recent snapshots and how everything works. But that will bring you to the skyfun.space website in whatever browser that you've chosen for your phone. And you'll need, of course, internet access for it. The fuel estimator works exactly the same as before. Depending on whether you've got switchable tanks or not, you'll have either 4 entries or 2 entries here. And then all your different phases of flight, fuel economy numbers, and how often you want to switch between fuel tanks. So that, of course, this isn't an actual fuel gauge; it's only an estimator. So you have to know how much fuel you had to start out with. But it actually is pretty accurate. I've used it several times, and it's pretty close. It's actually closer than the gauges in my plane because they're so crappy. So anyway, because I've gone in with a like a fuel stick and checked against these numbers, and they're pretty close. Okay, speaking of fuel, I'll go ahead and start that and show you something else. So here, that indicator, that yellow indicator, shows you what tank you're on. If you've only got it set up for a single fuel tank or non-switchable tanks, you'll just have the one on this side. You won't see both of them. So when this gets to the 30-minute mark, it'll give you a little indication that you can dismiss, so you can switch your tanks, and then this will move over to the other side and show it's slowly decreasing as you're flying. Timer works the same as before. There's nothing different. It starts a timer and it times out. When it times out, it'll give you a dialog that says whether you want to dismiss, start over, or change the time. So nothing different with that. I'm rushing through this because I want to get to that. I don't want this video to be insanely long. Reset level does exactly what it did before. It tells the Stratux to reset what it thinks is level flight. Reset G isn't a whole lot terribly useful. This is the G meter here. You notice if I bang the table, it's really sensitive. It's probably the scale is probably way too exaggerated, but that's what that is. So if anybody bangs into your plane, I guess you'll know. The next setting here is the miles per hour, or the units, sorry, for the speed gauge. So if I press that, it goes to knots. Press it again, goes to kilometers per hour if you're in a country that uses that. And I use mile per hour, so I'm going to leave it there. Calibrate Magnetometer, that's for this, so it won't do anything right now. I don't have it turned on yet. That's why this indicator is red. And then exit, and this button turns will shut your Stratux down gracefully. So if you're one of those people that just is blessed with a bad card or whatever, and you don't power it down gracefully, and your card gets corrupted, that's an option you can use. I have never had a problem with it. I always use the brand name cards, and way more capacity than I need. So if it is occasionally writing to the card, there's so much room on it that it doesn't matter. So that's what all those functions do. I'll go quickly scale this back out. You know what? This doesn't have the airspace turned on, so it doesn't have anything turned on. That's why we don't see anything on there. Okay, so now this one's the same as that one. Okay. When you press on the middle here, you get the bugs. Well, it used to be called the bug selector. Now it's just whatever selector. Because before there was just the wind and heading bugs, and that's all you could do. Here, what I just did was I turned all the overlays back on. You've got the runway extensions on the airports, the airspaces, that's all this stuff, and the altitudes. That's the gray text that you see in the different airspaces, showing you what the levels of the shelves and stuff are. And all traffic or close traffic toggles on whether you want to see all the traffic or just the close traffic. Close traffic is anything 5,000 feet above you or below you. So if you're in a busy airspace like this, you'll probably want to turn close traffic on, because you'll see stuff that's 30,000 feet above you, and it's kind of pointless. So the other functions are exactly the same. Heading, if I want to go 330, put it where you can see it. That's your heading bug. If you want to put a wind bug, you can do that. Let's put the wind bug at 55, and the wind speed is, say, 14 knots. So now you've got your wind bug and your heading bug. The wind bug shows what the speed you set was, if you long press on here, it will connect those and show you the effective crosswind and the delta angle between your heading and the wind. I actually find that useful. So I'll turn that off because it really clutters up the display. The rest of this, airports, it's kind of a poor man's version of what you have in an EFB. I'll bring up Dulles because it's got a ton of information. So those are all the frequencies. Yeah, and the list is so long, the screen isn't long enough for it. So I'll pick something a little more reasonable, Manassas. So that's all the Manassas frequencies, their elevation, and their runways. Yeah, it's a little bit simple, but you know, if you're going to get that detailed, you know, use your airplane's avionics or an EFB, because that's what most people do anyway. If somebody really wants all this on there, you know, let me know and I'll look into it. But most people use an EFB, so I didn't want to go crazy, you know, having templates and taxi diagrams and all kinds of other stuff that you get with an EFB. The rest, barometric pressure, that will set the barometric pressure on here. So you know, I can't use it right now. I will get to it. And clears the bugs that you set. Okay. Is there anything else? Yes, there is. If you click on the very corner of the display here, it'll show you your GPS status as well as any non-ADS-B traffic that it sees, which after, you know, as of a couple weeks ago, it shouldn't be much because everything should be ADS-B, except for maybe the low and slow guys. Okay. And you just dismiss it by pressing again. The direct to works exactly the same as an EFB. Well, not exactly the same, but close. You can select the range of airports that you want to see to go direct to. It defaults to 25 nautical miles, so if I want to go to Leesburg, it will show me the direct to route on there. And if I zoom out, you can see it's connected to KJYO. Okay, from to does the same thing, and this one's less useful unless you're like starting from an airport and you want to follow the exact same course that you would have plotted, say in an EFB. Say I'm going from Culpeper to Stafford. You know, it will still give me the heading to Stafford, but if I really want to follow that route, you know, I can use that as a guide. And what I'm talking about up here is it'll give you the heading that you're supposed to be flying and how far away the destination airport is. And this is kind of like a one-leg version of like a flight plan that you'd see on a full-blown EFB. So I think that covers everything that this will do. Now I'll go ahead and turn this on, and we'll go over some of how this works. And you'll see it says you probably can't read it, but it said connecting to Stratux, and then it connected, told me the IP, and then it starts feeding data, and you'll see that now these lights turned green, showing that it actually has the data coming from the I'm calling it wing thing for now. That may change, but for purposes of this video, if I say wing thing, I mean that. So you can see this display is showing several of the values that are coming from here. The way this works, if you're not familiar, the Stratux, this is basically an access point. Yeah, it's got the Stratux software on it as well, but when you connect to the Stratux, you're actually connecting to the access point where you have access to the Stratux data, where it's sending a GDL90 stream to your EFB, or in this case, it's using WebSockets. But it's exact same data. So when your EFB or Stratofier or whatever connects to the Stratux, it's actually connecting to the access point. And that's exactly what this is doing, is connecting to the access point, and then it's sending data on a broadcast address that on a specific port that both of these are listening to. So once it starts broadcasting and it gets a valid data stream, it says, "Oh, I'm seeing wing thing data," and it lights up that indicator, so you know that you're receiving something. You'll notice that on here, now there's now a number underneath there. That becomes the ground speed that used to be the speed coming from the Stratux, because that's all you have on the Stratux. So if I pick this up and blow into the pitot tube, you can see that it's actually changing, but the ground speed isn't doing anything. So I can blow 100 miles an hour. Okay, so that's what that sensor is, and those tubes are coiling around into this pitot sensor that's actually reading what the air pressure up against that tube is. And there's a little tiny hole for the static. And as of this recording, none of this, the airspeed has not been calibrated, and I haven't even, because the weather's been so bad, and I've just been so busy, I haven't had a chance to actually put it on the plane and fly it. I've flown I've driven this around in my car, and the speed seems pretty accurate, but I've never brought it up to like 130 miles an hour like you would in the air. And I have tested the magnetometer, and I do want to get into that a little bit, because I'm probably going to replace it with a better quality one. So anyway, that's what's happening here. Is this is sending all the sensor data to a over the Wi-Fi network that you're now a part of, whether you're using EFB or Stratux or Stratofier or anything else. It's all coming from the Stratux, so you're not actually connecting to this and this. All you have to do is connect to that, like you always did, to this. You can't see my hand. You're always connecting to the Stratux. So I'll go over some of these sensors that are on here and kind of let you know where things are at. This here is a BNO 055 9 degrees of freedom sensor from Adafruit. The orientation axes work very well, but the magnetometer just, it's really twitchy, and it's kind of slow and not terribly accurate. Some of that may be in the code, but even at rest, it's twitchy, and that's where the magnetometer calibration comes in on here, which I'll explain. It basically runs through an algorithm collecting. So what you'll do is you'll start the calibration, and then you'll take this and just kind of move it around like this to get all X, Y, and Z axis measurements from the magnetometer while it's calibrating. And what that's doing is collecting data, and then it's going to run an algorithm on that data and figure out how to calibrate the magnetometer to make it a lot more accurate. And it works a lot better than just not calibrating it at all. It's really far off without calibrating it. Calibrating it, I'm getting between 2 and 4 degrees of accuracy. And that's just kind of eyeballing it for now. I haven't actually written down any numbers, but it's roughly 2 to 4 degrees of accuracy. So what I want to do is replace that with a much better magnetometer, and it's got all those other sensors that I don't need. The Stratux already has a orientation sensor on it, so there's no need to have all that stuff. I'd like to get a dedicated magnetometer on there for a more accurate heading reading. So going forward, this altimeter sensor, if I can remember the model number, I think it's MPL115A2 or something like that. It's an Adafruit sensor as well, and it's very accurate. I'll probably stick with that one because it works well, and it calculates your pressure altitude automatically on the chip, So all you have to do is send it the barometric pressure that you've gotten from AWAS or whatever into onto the sensor, and then the sensor sends you back the actual altitude, which is being read back here. So for instance, now that it's running, I can do that. If I hit barometric pressure, and we'll use something a little crazy like 28 even. It's showing me that I'm at 1,920 feet, which obviously isn't accurate because I'm only at about somewhere between 300 and 400 feet to where I am. I think it's actually closer to 300. So I'll put it back to something. I don't even know what the actual barometric pressure is right now, but I'll just put it to 9.2. And on this wee tiny little display, I don't know if if the camera can actually focus on that. Let's see if I can make it focus. Yeah, I don't know if you can see that or not, but it actually says 29.92. It'll say whatever you've set it at. And that doesn't really matter for the actual user who's not testing this, but it's really handy just to glance over and see that the numbers that I'm getting from here are the numbers that I'm getting on here, and and anything that I've sent to it is reflected on the display. But the end the end goal is to not have that display because it's kind of pointless when you're in the air. You can't see it anyway. What else? Oh, so I went over the altimeter. The brains of the unit is an ESP32 microcontroller, or ESP32 based microcontroller. I think the name is Espressif. Makes the actual chip. The board is made by Heltec. They put all the goodies on it. The Bluetooth and the Wi-Fi and the screen and everything. The reason I went with this one is because it's got a beefy Wi-Fi antenna on it, and then you can see that little coil sticking up from the board. A lot of them just have a wire trace on the board for the Wi-Fi antenna. This blinking light is just a heartbeat. So there's code that's running on the microcontroller that's blinking that once every 2 seconds to tell me that it's working, or once per second, I guess. What else? The pitot-static sensor is I don't even remember. It's from 3D Robotics. It's one of the ones. It's a digital sensor. It's not analog. It's meant for a high-speed model aircraft. It's rated to 200 miles per hour. I haven't tested that. My Cherokee won't even go that fast. So whether it's actually rated to 200 miles an hour, we'll see. What I'm really more curious about is whether or not it will actually show 110 knots when I'm actually doing 110 knots. And like I said before, that's a 5 milliamp hour battery, or 5,000 milliamp hour battery, or 5 amp hour battery, and that's the battery charger, and that's the battery power circuit. Again, neither one of those may not be necessary in the final build. So that's how that works, and this is just switched to the straight to the power supply, so it just turns it off. Turn this back on. The only other thing to cover is this also has a temperature sensor in it. It actually has two temperature sensors. There's a temperature sensor in the pitot-static just for calibrating the pitot-static, and there's also just an outside air temperature on the altimeter, and that's what is displaying there. So it's 18.1 degrees in here right now. And I've tested that multiple times, and it's pretty close. So that is the actual temperature. So this guy here, I will be testing over the next week or two, and working out any bugs, calibrating everything, and starting to look into better hardware for the final build. A few people had asked about, because I posted this on Facebook on the Stratux users group, and a few people had asked about kits. Yeah, I can do that. It depends on how many people want kits. If there's only 5 people that want them, that's kind of pointless. But I'll certainly make the parts list available, and if somebody wants to build one, I'll freely give that away. But if somebody wants pre-made kits and they don't want to bother building and soldering and everything else, if enough people want them, yeah, I'll go ahead and start putting kits together. So I think that's about it. Hopefully in a few weeks I'll have more news and maybe something else to show. Okay, thanks for watching.